Okay, I just want to look at some of the modeling functions and how to build those. And so kind of the main idea here, usually, this isn't always, is that you usually come up with a, some type of drawing or a picture to help you figure out what's going on. And then typically after that, you come up with a formula. And then if that formula has, say, x and y in it, then you sub in for the y, so you get it in terms of one variable, so it's a function. So that's kind of the gist of it, I guess. Now, an easy one where you can kind of skip the middle step would be, for example, say you have something where they tell you that you have a semicircle that is inscribed in a rectangle. All right, so here's a rectangle, and you have a semicircle that's inscribed, so it's inside of it. All right. And then they might say something like, all right, we want you to find, say, the area. Oops, that didn't work very well, did it? Did it take? Nope, still didn't take. There we go. Okay, so they want you to find the area of that shape. All right, so, and the whole rectangle, not like the outside or the inside of the semicircle. I mean, they want you to find the area of this entire rectangle. And so you think about this and you're like, okay, what do I know? Well, I know that this has a radius. And so if you think about it, this would be a radius, so would that be a radius? So as you look at that, you're like, oh, wow. So this base is 2r and this height, because this would be at a right angle, is also at r. So you're like, oh, or area equals length times width. So there's your general formula. And so when you sub in, you're like, oh, 2r and r is 2r squared. And the nice thing is you can skip this subbing in another formula because this is a function. So because it only has one variable, it's a function of r. All right, so if you look at that, you're like, oh, wow, okay, so that wasn't too bad. All right, say I take that same problem and we focus on perimeters. So now we're like, okay, we want the perimeter of this rectangle as a function of the radius of that semicircle. Well, okay, this side is still r and this side is still 2r. So perimeter is the distance around. So I'm like, okay, you could write a formula if you want, like 2 width plus 2 length, or a plus b plus c plus d, some formula. But the reality is I can look and I can be like, wow, if I go around that rectangle, the distance around, oopsie, sorry, is 6r. And notice I only have r, so I could write that as a function with r as my variable. So perimeter as a function of r would be 6r. So that one's kind of nice because you have just a general formula and right away you just have r's, and so it's not that big a deal. Now, some of the ones that we did in class, let's look at one that we did in class, and I'll just try to go through this again, would be you have some type of, again, function, all right? And so it could be, I don't know, like y equals, say, 16 minus x squared or something like that. And so, and maybe you're only in the first quadrant, all right? So if you sub in 0, you can see that you're going to be up here at 16. And if you set this equals 0, you could see that if you solve that, you're going to get plus or minus 4, but again, we're only in first quadrant, so we're over here. And again, that's just part of that parabola, and again, doesn't have to be beautiful. This is just a sketch. And then it'd say something about having a rectangle or a right triangle, something inside of here. And they would tell you that probably one of the points is at the origin, and then the rest might vary. But there's for sure going to be a point on this curve, right? And in this case, we're going to say that it has a side that touches the y-axis, side that touches the x-axis, and then it has a point that's on the function. So ours is going to look like that. So again, just read carefully what it says. All right. And in this case, they're going to want us to find an area because we're probably going to want to maximize the area of that rectangle. All right, so again, go back to the steps I talked about earlier. You're going to write a general formula. So you need to have some background knowledge, like area of a circle is pi r squared, circumference of a circle is pi d, area of a rectangle is length times width, area of a triangle is half base times height, distance formula. Those kind of things you're going to have to know or be able to figure out. All right, so I have length and width. And so then think about what we're at here. This is 0, 0. And we're going to call this point x, y. And if you want to, you could label this guy 0, y, and this one's what? X, 0. But that doesn't matter as much. All right, so what is this distance? Well, that's your x. And what's this? So your length and width are x and y. And that, again, is still a formula because you have too many variables. So you need to convert it into a function. So on this type of problem, there's usually some type of formula, or there's a graph where you could figure out the formula, right? Like if I gave you this graph, the picture, you should be able to be like, oh, it's a parabola that's been turned upside down, so there's a reflection. It's been shifted to 16. So you could somehow be able to come out with that formula whether I give it to you or not. So the nice thing is this one's solved for y, so that's beautiful. So we're just going to sub that in right there. So 16 minus x squared. And we could distribute and get what? 16x minus x cubed. And we'll just call this a of x. So there I have my area formula for that scenario. So I took length times width, subbed in with a formula, and just distributed that to both, and that's what I get. So then usually what happens on these, and I don't have a graphing calculator with me right now, but typically what happens is you would graph this function to find their max or min. Now remember, this function is not the same as this picture over here. Okay, this is a length and width. This is a input would be width, output would be area. So this function is going to look different. All right, but what you're going to do is you would set your window. So let me see. I'm going to come up here and let me erase this up here so I have a little more space. All right, so what's going to happen is you're going to graph this function. And again, you know, it might have several curves, but you're going to set your window so your window kind of makes sense. So 0 to 4 for the width was kind of our input. So if I have 4, notice that would be, you know, 4 times that and 4 times that, we get 0. So, you know, if you have 0 to 4, you're good. If you want to make it a little larger, like 0 to 5, that doesn't hurt. And then your output is the area. So, you know, if it's 4 by 16, that's going to be outside of here, correct? So, you know, I don't know, pick a number, whatever you want. You could do 60, 50. You can always change it. You can even do 100. It doesn't matter as long as it's in the ballpark. All right, and so what's going to happen is, you know, I don't necessarily know what's happening to that curve outside of this. I mean, I can figure out because that's odd and, you know, different things. But and behavior, all that good stuff. But, you know, for our purposes, you're going to just look at your window, and so you're going to see something that looks probably like that. All right, and again, I don't have my graphing calculator, so these are just estimates. All right, and there's going to be a max up there somewhere. And so then what you're going to do is you're going to go second calculate on your graphing calculator. All right, and go down to either 3 or 4. It's going to say max. Right, and so then it's going to ask you for the left bound. So you are going to go on the left side. So trace on the left side and hit enter, put a boundary over there. And then you are going to go to trace it over to the right side and hit enter there. So that's going to be your right boundary. And then you'll hit enter one more time. And then what's going to happen at the bottom of your screen, it's going to say x equals. And then over here, it's going to say y equal. And so that x, whatever that number is, that's going to be the value for the width that gives you the maximum area. So whatever that number is, that is the width. Now your y, again, remember what y is. In your function, y, your output is area. So your input down here is width, but your output is area. So let me put width there. All right, so then whatever the y value is, that is the maximum area that that rectangle can have.